In our final lesson, we'll talk about some guessing strategies you can use. So, of course, ideally, you'll learn all the rules of probability and be able to solve all the problems. But what if you get stuck at a problem, don't even know how to begin? What are some ways that you can guess effectively on a probability problem? So, first of all, use your instincts. And as you work with probability problems over time, you will develop instincts. So, for example, if it's something like flipping a coin 10 times and getting 8 heads, something like that's not going to be very, very likely. And so if one of the answer choices is like 0.8 or 0.9, you know that an event like that is not going to happen 80% or 90% of the time. So something like that would simply be unreasonable and you could eliminate it. So always use your real world instincts about, would something like this be really likely, really unlikely? And if you can use that information, use that to eliminate some answer choices. Second, if the complement rule is clearly used in a problem, even if you don't know how to solve the problem, look for complementary probabilities in the answers. Now, what do I mean by this? Suppose we have this question. If blah, blah, what is the probability that at least one blah, 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 blah? So we have no idea what this question is about. Suppose you look at the question and it might as well be written in blah, blah. You have no idea what the question is actually asking. But you spot these magic words, at least one, and you remember, oh, in an at least one problem, the quick way to do it is using the complement rule. So, of course, that's what the test maker has in mind. Now, let's think about this. If the test maker wants a probability of A, of course, the way that you figure this out is it's 1 minus the probability of not A. Well, of course, sometimes people go through all the work of figuring out the probability of not A, and they forget this final step of subtracting it from 1. This is a very common mistake. Because this is a common mistake, it's always true that on a problem where the complement rule is used, even though this is the correct answer, this will also appear as a trap answer. The test maker always will put the likely mistake as a trap answer. And so that means if we see pairs of answers that are complements, that's a very good clue that one of those is the correct answer. So for example, we look at the answer choices here. These two answers are complements. The other answers don't have their complement listed. So it's very likely that those are not the answers, and we can guess from one of these two choices. And of course, if you can eliminate 3 choices and guess from the remaining 2, your odds are much, much higher, and it's to your advantage to do so. Finally, think about overlap. And this is a very tricky issue about probability. Suppose, for example, the probability of A is 0.7, the probability of B is 0.8. And we're asked some question about A and B, A or B, something like this. Well, notice, first of all, if one thing is happening 70% of the time and one thing is happening 80% of the time, there's absolutely no way that they could be mutually exclusive. Because there's no way that you could have 70% of the time and 80% of the time never touching each other. They're going to have to overlap. One way to view this is visually. So, for example, if this is the 80% of the time, so this would be the whole space, that would be 1. This would be B, which is 0.8, and so that just leaves a little 0.2 on the outside. Suppose we want to have them have minimum overlap. Well, minimum overlap, then we'd push A all the way over here, 0.7, and so that means there'd be a 0.3 on the outside over on this side, and that means their overlap zone would be 0.5. And so it means that if we have a minimum of overlap, notice that what we have here is that the probability of A or B equals 1. The probability of A and B equals 0.5. So we're trying to make the overlap a minimum. What if we try and make the overlap a maximum? Well, then we'll kind of push everything to the same side. Here's our 1. Here's our B. We'll push it to the left side. That's our 0.8. And we'll push A to the left side also. And it turns out that, first of all, the OR region is just the probability of B now. Probability of A or B, because A is inside B. And so that's the probability of OR. And the probability of and, well, now that's the size of A, probability of A and B. Everywhere where A is, B is also. So that's 0.7. So notice, even if we don't know anything about the particulars of the situation, just thinking about overlap, we know that the probability of or has to be somewhere in this range. The probability of and has to be somewhere in this range. So that would allow us to eliminate answer choices. In the rare case that we had an inequality question about probability, we might be able to answer the question purely by thinking about this overlap. These are some strategies you can use. Even if you don't understand the question, there are still effective ways to eliminate the answers so that you can guess effectively on these problems.